Moving on to question number 2, I will show you how to simulate samples, each with 20 cables from the normal distribution, and then I'll show you how to calculate power based off of that simulated data. I'm not going to show exactly the same simulation that you will need to do for question number 2, though it will be similar. First, if you're going to use Excel, I highly recommend that you keep everything nice and neat in different tabs so that when we go back and look through your Excel file, it's easy for us to navigate. I've moved all the calculations I did for question number 1 over here to a new spreadsheet that's called question number 1. The first spreadsheet that has the original data, I should keep that clean and call this provided data, or something along those lines. Okay, so now I'm going to go to question number 2. So I should type here question 2. To add more sheets, you just press this little button, and then to rename it, you just kind of double click on it. Alright, so now I'm thinking about question 2, and I need to generate 200 samples, each with 20 cables. So first column, I might name this the cable ID. So 1, 2, 3. I can highlight this and then drag it down to 20. So that's 20 different cables. Next, this is simulation 1, or let's call this cable strength sim 1, something along those lines. Okay, so this is simulation 1, the cable strengths for the first simulated data set. Okay, so if I'm using Excel, down here at the bottom I provided with a function to generate normal random data. So let's use that. Okay, instead of doing exactly what you guys need to do, I'm going to change the mean and standard deviation. So I'm going to generate from the normal 0, 1 distribution, from the z distribution basically. Okay, so I'm going to drag that down to 20. So this is basically 20 different cable strengths. You'll notice already that this is a little odd because I have negative cable strength. There's no such thing as a negative strength, right? So a cable only has positive strength. Well, this normal distribution is not the best assumption for the cable strengths due to this fact. However, I just want us to move forward with it and go ahead and use this assumption. And then later, we'll use a better distribution. For part 3, we'll use the log normal, which is strictly positive, so we know we won't have this problem with the negative cable strengths. So for right now, we'll just move forward with it, despite the fact that it's unrealistic. So once I have one simulated data set, I can highlight it all. So when I highlight, I click, choose the top cell, and then press Shift, Control, down. So Shift, Control, and then the down arrow. That'll highlight all the data. Then I go over here and I press this little, so my cursor becomes a little cross. And then you see as I'm scrolling across, Excel will tell me in the bottom here, it'll say Sim 7, right? So I know how far I've gone, Sim 8, so I need to just scroll it over until I get to 200. So let's scroll it back. I went too far. So until we get to 200. Let's see. There it is, 200. So now I can highlight all the data and then double click on one of these, and that way I can, the cells will automatically adjust to be in the right width. Okay. I don't need to start this on F. I'm going to delete those cells so it starts on A. Alright, so now I'm ready to calculate the power. So to calculate power, first, so what you're going to have to do is basically run a test and see if you reject the null hypothesis. Remember, power is the probability of rejecting the null hypothesis under the assumption that the null is, in fact, something that you should reject. Okay? So, in this case, you will actually calculate this and really see here in part B that the null is something that we should be rejecting. So, basically we just need to calculate the probability of rejecting the null hypothesis. Okay? Because this data is simulated under the assumption that the null is something that we should reject. The null is not true. This data is simulated under the alternative hypothesis, basically. Okay, so I should calculate my p hat, right? This is the proportion of cables that are less than that will break under a load of 10 kilonewtons. So I can use that COUNTIF function. So I'm going to highlight all this. So COUNTIF, and then less than or equal to 10. All right, and then the number that are less than or equal to 10 divided by 20, that'll be the proportion. Okay, in this case, it's 1 because I'm simulating all of this data under normal 0, 1, so that they're all very low values. So for the purpose of this, I'm going to change this number to be less than 1. Okay? Okay, so now I'm ready to calculate the test statistic, TS. Now TS depends on what the null hypothesis, what you're testing, right? So this P naught. For the purpose of this demonstration, I'm going to define that P naught 0.7. For us, I think it will be 0.3 for you. So I'm going to do it slightly different. Okay, so what is TS? It's the P hat minus P naught. So that's on the top, so I have to put it in parentheses. Divided by the square root of P naught, so click on that cell, times 1 minus P naught, divided by 20. Okay, so there's my test statistic. This test statistic, it's going to be the same as I scroll across for all the simulations. I mean, the P hat will change, but this P naught will stay the same. So to lock in that cell, we can use these dollar signs that locks B22 to always be B22. Okay, so you use the dollar signs before and after the B. Alright, now I'm ready to calculate the p-value based off of that test statistic. So just like how we did in question number 1, we'll use the norm dist function. So norm dist, and then we'll give it the test statistic. We'll say 0, then 1, and it's asking if it's cumulative. Yes, we want cumulative. And then if you want the left tail, you would leave it like that. If you want the right tail, you would say 1 minus it. Okay, and then we need to say if we're going to reject or not. So reject HO, I'm going to do an indicator where if I am going to reject, I'm going to say it's equal to 0 or it's equal to 1, and then if I'm not going to reject, then it's equal to 0. So if the p-value is less than 0.05, then reject, so that's 1, otherwise it's 0. So this is just going to be zeros and ones. Okay, now I'm ready to just drag P hat through the reject, right? So P naught stays the same for all these simulations, so I just leave it there. But all these other ones, I'm going to drag it all the way till I get to 200. Okay, so remember to drag, I just kind of picked up that corner and I moved it. Alright, so now that I have this, scroll back. And now I'm ready to calculate power. Remember, power will just be the probability that I'm going to reject, right? The data is simulated under the assumption that the null is the alternative is true, right? The null is not true. So the probability that I'm going to reject will just be the mean, or the Excel function for mean is average. Okay, so the average of all the zeros and ones, right? The average is basically what? That's the sum of all the ones divided by the total number that there are, right? So that's an estimate of the probability of rejecting. So to highlight all of these, I can drag like this, or I could press on the cell, and then, let's see, I can press on the cell, first cell, and then press Shift, Control, and then the sideways button, and then end the parentheses. So when I end the parentheses, I'm working up here. Okay, end the parentheses, and then press Enter. Now give me an estimate of the power. So in this test, the power of the test was 0.37. So you'll do something very similar for parts I and II. Okay, for the second part, what you're changing is that alpha. So your decision to reject or accept will, instead of this being 0.5, you'll have to change it to 0.01.